Okay, we will pick up the pace on our understanding of where electrons are in atoms by considering modern atomic orbital theory. We will look at precisely where the electrons are in each element up through argon. This is screencast 5.8. Okay, Bohr showed us that electrons reside in shells. Lots of evidence for it. You got a nucleus, then you've got your first shell, second shell, third shell. That's fine. The modern understanding now is that you still have these shells. And there's the first shell. Electrons are in that. Here's the second shell. A couple of electrons are in that, but it's now subdivided. Also in the second shell, you have p orbitals. Like that. Cut 8 electrons there. Move on to the third shell, and you have also s as well as p orbitals, where an orbital is a pair of electrons. Think of this as subshells, dividing up those shells that seem so familiar to us now after the work of Bohr, but now there's details within it. So we have a series of shells, a number of electrons that are in each shell, and then subshells. Each one is a pair of electrons. This kind of a bricks within a shell kind of idea might get you started, but this one is closer to reality. And each one has a sort of configuration, a shorthand if you will, where you have a certain level, an orbital, and the number of electrons in it. Okay, so the first shell. Number of electrons that can be in the first shell, think of it as this red shell right there. 2 electrons. It's only 2 electrons, one pair, so that's one orbital, and it's just an S spherical type shell, and it looks like that. Since it can hold 2 electrons, we say it's the first shell. It's an S orbital. It holds 2 electrons. The electron configuration of helium is 1s2. It has 2 electrons, right? Helium has 2 electrons in its uncharged state, so there it is. Second shell can hold 8 electrons. The order they go in is 2 for the S, and it looks like that, a bigger sphere. And so we say 2s2. That brings us to atomic number 4. But it also has some p orbitals. That one, and that one. Remember we showed it back on the previous over here. So that brings us another 6 for our total of 8. And we say that these last 6 are called the 2p6. 3 subshell. 3 pairs of orbitals. This brings us through neon. Now we're in the third shell. It begins, just like the second one did, with an s orbital. Let's make it even bigger. It can hold 2 electrons, so its electron configuration is 3s2. We're up to atomic number 12. And let's do those 3 sets of p orbitals, p sub x, p sub y, and p sub z. Can you imagine electrons filling up in that order? This brings us to argon. There should be a little 6 right there. We would say that the electron configuration of argon is 1s2, 2s2, 2p6, 3s2, 3p6. It's wise to stop there because you might recall from that unusual Aufbau order that electrons will start filling inner shells, right? It goes from 4s2 to 3d10, things like that. So we have to be careful when we get larger. But this is a nice electron configuration through argon, and this is screencast 5.8.